All right, let's continue with the dynamics chapter. In 13D, we're going to look at connected systems. So, um, usually there will be a rope system that will link two objects or multiple objects or particles. Um, the way we're going to model the connection between the different particles is with the rope that is considered to have zero mass, okay, and by applying the laws of motion on the rope, we'll see that you have two opposite forces uh, that have the same magnitude and opposite direction. Usually we'll call it magnitude T for tension on each of the ropes if you have more than two systems. So here is how we start approaching that on the model. So here you have two objects usually. Okay, so it's this one has a thrust force. So let's say that's a car, and here you have a trailer. You have a connection between the two. It's a rope, a chain, whichever. It's really under, it's constantly under tension. It's not, so if it's constantly under tension, it's actually not a rope, because a rope gets doesn't always get um, keep straight under tension. The reality, it can kind of get loose. So think about it as a, I don't know, a metal bar, something like that. So when we talk about connected system, the connection is the rope that has two opposite pull tension, and that's all we're going to do with that rope system. Then we're going to ignore it. After that, the two systems we're going to focus on, the first system is the car that has all those four forces applied onto. So the thrust force, the reaction from the ground, the weight force, and then the tension of the rope on the car. That's the first system. The second system is the trailer, reaction force from the ground, a weight force downwards, and a tension from the rope, but this time in the opposite direction. Okay? They're moving on a smooth plane. Smooth plane implies no friction. We're still going to look later on friction cases anyway. All right. So those are examples using connected particles. So a rope will bend around a pulley, a combination with an inclined plane, multiple system, three systems. I know there's a lot of arrows, but what you need to do is isolate each system. So W1 here, W1 and W1 is one system. W2 is your second system, and so on. So we can do three systems and so on. Okay, now here you have two systems. You actually have two unknowns. The first unknown is T, and the second unknown is the acceleration of the whole connected systems, and each system actually have the same acceleration. Okay, so keep that in mind. So two systems, two unknowns. Let's look at the last one that is a little bit trickier. You have three systems and three unknowns as well. T1, one unknown, T2, and your acceleration, that gives you three unknowns. Okay. All right. So linear motion, you're still going to use your Cartesian plane because you're going to have vertical forces, your weight force and your reaction forces. The first thing you should do when you pause the video is read the text and draw a diagram and annotate all the values that you know of. Okay, if you don't know their values, assign a variable. All right, I'm going to continue. So you have your first car has a normal reaction and a weight, which is your Yes, so the ahead is 1 ton, which is 1,000 kilograms. The other one is 750 kilograms. You have a tow rope. um, S and T are the pull force on either sides of the rope, so they have to be equal. um, the towing car has a traction force of 3,000 Newton, which is this one. Thank God there's no friction. So the acceleration of the two cars, now they're all moving to the right of an amount that we're going to call A. So we apply Newton's law on across. We project on the horizontal axis. Positive is to the right, so that gives us that from the second law of motion. Okay, so we get the value A. Secondly, we apply the same law, but this time to the second vehicle, and we're gonna get the amount, because we have already determined the acceleration. We can determine the amount of the tension in the rope. Okay, now the diagram, three systems. So you have a 4, 5, 11. Release from rest. I'm just trying to remember, because I cut off the amount. Oh, that's 11, so it's gonna be 4 and 5. Okay, now what you need to think of is 4 and 5, which is 9, that's less than 11, so it's gonna move that way. It's gonna go down that way towards the heavier mass. Okay, so you have three unknowns: the acceleration, t1 and t2. They all have linear motion. Okay, and what you could do is consider that it's going that way, which is clockwise, and you will apply that to each system, so to the 4, the 5, and the 11 kilogram masses. That will give you three equations. Okay, so you do that for the first one. So you have on the right is m times a, so it's at 11a going downwards. Downwards you have the weight force, which is all 11 kilograms, so that's 11g. G is all gravity, and t1 is in the opposite direction, hence the negative. Okay, with the 5 kilo, it has only t2, so here is the 5 kilo. So you have the acceleration is going that way. Okay, so it's going upwards. The weight force is downwards, so it's going to be negative 5g, and t2 on the 5 kilogram mass is in the same direction of the acceleration, so it's positive. Okay, so just pay attention to the sign. With a 4 kilogram mass, t1 is positive because it's in the same direction of the acceleration. Again, it's going upwards. You have the minus t2 and the minus 4g. Don't forget though the minus t2. There's two ropes applying to the 4 kilogram mass. So we have three equations, different ways of solving those. Okay, so here what they do is they add 1 and 3 to something's going to disappear or not. 1 and 3. We get rid of we eliminating t1, so that gives us only an equation in t2. So we do that between 1 and 3. That generate a fourth equation that we're gonna mix up with the second equation. So but this time by adding 2 and 4, we end up with the acceleration, which is here. And then with that acceleration, you go backwards. You substitute into equation 4 to get the t2 value. and then in equation 3 to get the T1 value. Okay, so here's the working out. Have a pause this if you want to check and double check and see how they're doing their work. And that's it for 13D. All right, and I'll see you later.